Hello. In this video, I'll be talking about production cost and the profit functions. And of course, we'll be looking at the relationship between the two. Okay. So the total cost is, of course, total fixed cost plus total variable cost. And that is the short run. Okay. Is a short run concept because in the long run, okay, all costs are going to be variable. So there's different way to express we can also put total cost equals total fixed cost plus px x. And so that's a different way to explain express the total variable cost. Actually, I have it here. Okay, so we can express total cost like this. The production function, okay, y is a function of x. You know that, right? Okay, but we'll see at the next page that we can also write the x function as x as a function of y to make. So how do you compute those costs? The average fixed cost is, of course, the total fixed cost divided by y. Average variable cost, total variable cost divided by y. But we can also express it that way, px times x, okay? And here, what we see here is the inverse of the average. So I explained that here, okay? We know that average physical product is y divided by x. So 1 divided by average physical product. This is too messy now. Average physical product is going to be x divided by y, and that's what we have over here. And so the average physical product, the average variable cost, sorry, can also be expressed in this form here. So the average total cost, indeed, total cost divided by y, and marginal cost is the change in total cost divided by the change in y. The marginal cost, what it shows, okay, it shows the change in total cost. So how much total cost is changing as we are typically usually increasing output, okay, by 1 unit. So if we increase output by 1 unit, we try to understand how that affects total cost. The cost function can be estimated on 2 different ways, okay? That's what I referred to earlier. Just as earlier, okay? And so total cost equals total fixed cost plus total variable cost, okay? And here is going to be a function, no, actually. If we express indirectly, use the production function, okay, then we are going to be expressing y as a function of x. Okay, if y is a function of x, the variable cost is actually always a function of y, right? And so if you have a production function that y, we need to get the x back over here. So I'm going to work one example here, where is the average total cost equals 100 minus 3 y squared plus 4 y to the power third. And you want to calculate the total physical cost, so that is easy, it's 100, okay, here. It doesn't move. The average variable cost is the remaining over here. So now we want to look at, so this is total variable cost, not average. And so the total variable cost is going to come here. So the average variable cost is, of course, total variable cost divided by y. So is minus, okay. So we divide minus 3 y squared plus 4 right here. Again, minus 3 y squared plus 4 y cube divided by y. Okay, and so we'll move this, and this become 2, and this one, that's what gives us 3y plus 4y squared. And so when y is equals 2, the average variable cost is going to be minus 3 times 2 plus 4 times 2 and square, which is equal to minus 6 plus 16, right? So that's equals 10, equals average variable costs when x equals 2. So we know the total variable cost, okay? The total variable cost equals minus 3y squared plus 4y cubed. And so when y equals 2, you substitute this. So at 3, you have this function here, and which gives us 20. The marginal cost is the derivative of the total cost. So it's also straightforward. We just take the derivative of the total cost. I'm looking at the total cost there. Of course, there's nothing here. So equals minus 6y plus 12 y squared. So when y equals 2, then marginal cost equals minus 6 plus 2 plus 12 2 square. Okay, and we can compute that. Now we want to know at which level of y the average variable cost is at the minimum. So to find an extreme point, okay, to find an extreme point, so minimum is an extreme point, right? So we have average variable cost there, okay. An extreme point, we set that function, the derivative to that function is equal to 0. So we'll take the derivative of the average variable cost divided by d of y, and we'll set that to 0. And so the derivative of the average variable costs, so our average variable cost is, let's put it here, minus 3y plus 4y squared. And so the derivative of the average variable cost is going to be equals to minus 3 plus 8y. And so we're going to set this to 0 and we'll derive y. So that means 8y equals 3 and y equals 3 divided by 8. Okay, so when y is at this level, then the average variable cost is going to be at its minimum. And what it is really is the average variable cost is going to be go down and then go up again. Okay, so that at this level we have this expressed in function of y, so that's why we can have the y directly here. So one more example. Let's consider the production function that is equal to $70 plus 2x. So if you notice, right, the average, the cost function is a function of y. But the production function is a function of x. And so if we are asked to compute elasticity of production, we've done that a few times already, is going to be marginal physical product divided by average physical product. Okay, I'm looking for one more cost problem. I can find it. So this is just so a reminder, and if you are asked at tree level, the marginal cost is 0. So we'll take the derivative of the marginal cost. Okay. Divided by T of sorry, I lost my example. Okay. Let's finish this. Okay. Sorry guys, I'm going to skip this Now I'll take one more example. I'll work with it, but so that has to be a function of y. Okay. So to do this, we'll have to take the inverse of this function. Okay. But I don't want to get into that here because I don't want to ask you. It's a little bit more complicated. If average variable cost functions equals y squared minus 3y plus 4. Okay. To find y when the average variable cost is at the minimum. And so we are going to take derivative of average variable cost, derivative of y with respect to y, derivative of average variable cost with respect to y, and we set it to 0. So it's 2y minus 3 equals 0. And so y will be equal to 3 third, okay, or 1.5. And so if we want to derive, so we have the average variable cost here, okay? One also question is derive total cost, okay, from the average variable cost. And so we know that total costs equals, sorry, we know that average variable cost equals total costs divided by y. And so multiply this. So total cost will be equal to average variable cost time y. Okay. So our total cost in the example, we add y everywhere. It's going to be y squared times y, y to the power 3 minus 3 doesn't change, y squared plus 4y. Okay, so I will leave you here. I hope this helped a little bit, and I will continue recording. Thank you.